All right. Hi, everybody, and thanks very much for coming to this learning series. Today's webinar will be about optimizing cost and efficiency on AWS, one of my favorite subjects. My name's Peter Shee, and I'm a commercial architect at AWS, and I help customers optimize spend and realize business value on AWS. On hand with us today are experts in optimization and commercials. So if you have any questions during the webinar, feel free to answer or ask your questions into the question box on the side panel. So today's agenda. We'll be sharing how AWS helps customers realize value and save cost. We'll be sharing the different cost optimization levers and tools available to customers to optimize cost and manage spend as well. We'll be covering also at a high level the commercial management aspects of using cloud. And so these are the things that help accelerate cost optimization. We'll be sharing some finance team considerations as well. So cloud is fairly different to traditional IT infrastructure, and we'll be stating those differences and mentioning some methods by which customers address these differences. And finally, we'll wrap up with some next steps, surveys, and question and answers. So we have about 10 minutes of question and answer time at the end, which I'll go through any questions asked during the webinar. And so to whet your appetite to start, I'll talk about how AWS helps you realize value and save costs. And so in terms of understanding the value of cloud, think back to the times when the Industrial Revolution was happening, pre-times where electrical distributors were available. Companies and organizations and people had to build their own power plants. And so what that meant was it was fairly labor and time intensive. You had to have your own skills and you needed to manage the repairs around that. And so when the Industrial Revolution happened, many power suppliers appeared, and what people were able to do instead was to essentially plug into a grid. Another benefit was efficiency upgrades and improvements to the system came with the grid. And so innovation was baked into what you received on the buyer's end. And so in today's context, it's a similar case. Traditionally, customers and organizations built their own data centers, managed their own servers with large upfront investment, and were responsible for upgrades. New capabilities were only really available every IT refresh cycle, typically 3 to 5 years. And so fast forwarding to the 20th century, what we have is pay-as-you-go computing available through cloud. Companies like AWS have teams of engineers who are constantly working to improve the platform and innovate on our customers' behalf. And so you get access to automatic upgrades and a very feature-rich platform. And so AWS also lets our customers fit cost to today's demand. Traditional infrastructure, because of the long lead times and procurement times, customers needed to provision for peak. And so, for example, if you had customers visiting your website during Christmas and you expect a peak, then several months ahead of time, you already need to buy for that peak capacity. On AWS, it's different. You can provision for today's needs and today's demand, which means you can hug your workloads instead of your servers. AWS also lowers prices over time, and you can see that as we grow, we lower prices for our customers through efficiencies of scale, and that delivers a better customer experience for all of our customers. And so since we've begun, we've had 62 different price reductions over time, and many of which without any cloud competitors around. AWS also shares with customers how to save on AWS through webinars like this and many talks. One example being a reInvent talk in 2016, which talks about how to architect in a way that optimizes spend. And so a combination of all of this has resulted in some significant customer outcomes. So for News Corp, they've saved over $100 million in avoided capital over 3 years. Adroll are saving a significant amount both on fixed costs and operational costs. And GE has estimated that they've reduced the total cost of ownership of IT infrastructure by about 52%. And so you note in their quote, they've also mentioned that it is a byproduct of doing the right thing. And so that's what this webinar is largely about, sharing with you what is the right thing. And so keep in mind, cost savings are also only really the tip of the iceberg. There's a lot of business agility benefits. For example, Kellogg's company was able to do 10 times as much computing at half the cost because they were able to access cheap computing on demand, pay-as-you-go. That improved their ability to innovate, push more projects through the project pipeline, and have projects complete faster. Operational resilience is improved, and the CIO of Capital One stated that they feel that they can operate more securely on AWS Cloud than on their own traditional infrastructure. You have better global reach, so at the touch of the button, you can access any region you like within the globe that AWS reaches. Better staff and resource efficiency through automation, and some customers I've worked with have realized multi-million-dollar new revenue streams through additional computing power. And you can find out more at the various case studies found at the link below. And so let's start talking about the different cost optimization levers and tools available to you on the platform to help you optimize spend. And so when you move from owned infrastructure onto AWS with some optimization, typically you save about 20 to 50%. Although outside the scope of this webinar, highly optimized AWS environments have been measured to save about 90% of spend through serverless architectures. And so how do we do this? Well, the first main pillar of cost optimization that we talk about with customers is right-sizing your resources. And so traditionally, because you had to provision for peak, you provision resources that are larger than required for today's needs. And so right-sizing is about shrinking your resources down to what you actually need. The second major lever or pillar is increasing elasticity. And so that's about meeting internal demand when you need to. So developers go home at night, you can switch things off. And meeting external demand through architecture patterns like auto-scaling. So you scale up when there's demand and you scale down when there's less demand. AWS also provides a few different pricing models to fit your business needs, which I'll go into detail a bit later. And there are many different types of storage as well. So there are cheaper storage for lower performance needs and slightly more expensive storage for normal performance needs. Summarizing that, it's really about using things more efficiently, using less things, or simply paying less. And so getting into a bit of detail about the first pillar, right-sizing. And so as mentioned, it's about selecting the cheapest resource or instance whilst still meeting performance needs. And so for computing, typically customers look at CPU, memory, storage, and network. So let me give you one example. You migrate your workloads to AWS, you provision some resources, and you start running. And you match perhaps the size of the resource to what you had in traditional infrastructure. You have a look at the monitoring tools provided by AWS, like CloudWatch, and you check some metrics. And you notice that there's plenty of headroom to spare. And so you resize the instance to something smaller. You review that your application is still working okay. And in this case, we've managed to save 87%. And so doing that case by case might take a while. So AWS also provides tools to help you in this space. The first tool is EC2 right-sizing tool, and you can find that at the link there, and I'll provide a demo of that shortly. The second tool is AWS Trusted Advisor, which comes with business support and enterprise support, and it points out idle resources, and I'll demo that shortly as well. So the first demo is about EC2 right-sizing, and it's a tool that deploys a framework and produces a report recommending instance changes based on, I believe, 14 days of usage. So here's the website. If you search up EC2 right-sizing, this is the first thing that typically comes up, and the web slides will be provided at the end of this webinar via email, so you can use the link there as well. So when I first launched this myself, it took about 15 minutes to set up, so very quick. You deploy the solution, and it takes you to a bit of documentation and a button to launch the solution. And so what it launches with a few parameters is a CloudFormation template. And for the newer users, what CloudFormation is infrastructure as code, essentially. And so AWS and customers within their own company are able to share infrastructure templates with each other where you're able to update specific parameters. And so this particular template gives you a report that analyzes utilization and usage of your resources, and it provides recommendations for more efficient use. And you can see my one is called EC2 Right-Sizing Sydney, and it's been launched. And one of its outputs is a bucket name, which is stored on my Amazon S3 storage. And so if I navigate to that bucket, you can see a few files within the bucket that have been produced. And one of these files is the results right-sizing. And so here's one I prepared earlier, and the output of results right-sizing. And you can see, although text is a little bit small, it talks about the region, the instance ID, what you're currently running, and it recommends something new. And so based on what you're currently running, considering CPU, memory, disk, and network, it recommends something new and estimates the approximate saving you're going to get. And so in my case, because I'm not running a very big environment, this has only found $90 per month, but depending on your environments, you may be able to find significant savings. And so using this report, I see that my M4 X large resource is recommended to be changed to a T2 X large. So understand that this operates over a certain time period, and you'd want to run this report during your business peak so that you have crossed your business peak to ensure the data reflects peak needs. Of course, with auto scaling, that can also be avoided as well. And so I'm going to change my resource from an M4 X large to a T2 X large in my console here. And you can see in my console, in my EC2 console, I have my right size test, and it's running M4 X large. So all I have to do, and typically this is for dev test workloads where you don't have a change process around, you can right-click the instance state, stop the instance, and it'll ask if you want to stop. You stop it, and all you have to do next is right-click the instance, and after it's stopped, it'll let you change the instance type, and that'll turn white. You change the instance type, and then instance state, start it again, and there you go. New resource priced at a different amount with a lower instance type. So going back to the slides, the second pillar is about increasing elasticity. And so it's all about, as mentioned earlier, hugging your workloads instead of your servers. And so from a dev test perspective, typically our developers only need their resources perhaps 10 hours a day, maybe more. But if they do only need their resources 10 hours a day, what that means is it can be turned off outside of working hours if the architecture pattern allows. And so what that means is it can save you up to 70%. Newly launched this year is also RDS databases, and they can be turned off as well, so they can experience similar savings to this. And so some tools that help in the space include a Lambda Start-Stop guide, an EC2 instance scheduler, which I'll demonstrate shortly. We also have third-party managed solutions by companies like GorillaStack. And the additional benefits those companies and third parties provide are things like warnings and integrations with Slack, which is a chat system used by many developer teams, so that you can snooze instant shutdown where developers happen to be working late. And finally, to mention, as described earlier, auto-scaling. So auto-scaling is about meeting external demand as opposed to internal team demand. And so a quick demonstration of EC2 Instance Scheduler and how that can help you save. So you can find EC2 Instance Scheduler here at the link in the slides, as well as searching online. And a bit of documentation, bit of description on how it works. And if I click Deploy Solution, it'll take me to more detailed documentation. And similar to the other solution, this one only took about 5 or 10 minutes for me to deploy. And so you launch the solution, and what it creates is another CloudFormation stack. And you can see here, my EC2 Instance Scheduler is described here. And so I'll go quickly into some details about the parameters that you specify in here. And so I tell my resources that they turn on very early, 1:30 in the morning, and they turn off late at night at 11 p.m. However, you can tailor this to your team's needs. Another key input here is the tag name. And so on AWS, you can tag many of your resources, the vast majority. And in this case, when I tag my computing resources with this tag, it tells this CloudFormation stack and script to check any resource with that tag and apply these on-off times based on what I've specified here. And so you can see in my scheduling test example here, under tags, I have the tag mentioned earlier called scheduler EC2 Start-Stop, and I've set its value to true. And so what that does is it starts turning on and off based on the parameters I've described earlier. And not only that, you can specify custom parameters here as well. So if this doesn't fit the default, you can define for itself on a case-by-case basis when you'd like it to switch on and off. So that can save customers up to 70%, and in some cases even more, because some customers actually define that resources switch off at night, and they don't switch on in the morning unless developers click a button and tell it to switch on. We've also got advanced customers who've actually tied in resource which switch on and off with their badge swipe into their office premises. And so when developers leave for lunch, the resources switch off. When they go on holiday, their resources switch off, and only when they come into the office that their resources switch on. So the third pillar is leveraging the right pricing model. And AWS provides 3 different pricing models: reserved instances, which I'll be describing in detail here; EC2 Spot, which is outside of the scope of this webinar, but I'll describe briefly; and finally, on demand, which is the default pricing model you get when you turn on resources. And so going into detail about reserved instances. Reserved instances are, think of them like discount coupon booklets. So each reserved instance is an entire booklet, and the number of coupons inside that booklet is equal to the number of hours over the period of your reserved instance. And so if you buy a 1-year reserved instance, it has the number of coupons equal to the number of hours in a year. And what the coupon does is it provides you with a discount in exchange for commitment. And each individual coupon expires at the end of each hour. And so what that means is it's ideal to be used for always-on workloads, but it can also be used to save for not always-on workloads, because the discount may be more significant than the time in which the instance is off. And finally, Keep in mind, reserved instances, despite its name, they're a financial construct or layer on top of your AWS infrastructure. And so they're not tied to specific resources and physical machines, but rather they're a financial layer that provides discount and also capacity reservation. And so the impact for that, for some customers, has been such as 39% decrease in unit costs. And so you can see in this example, after the third month, the customer purchased a significant amount of reserved instances, and you can see the RI, or reserved instance coverage, go up, and this drove a large decrease in unit cost. So as mentioned, they're best used for always-on resources, but they can still be used to save money for not always-on. They save up to 75%, but typically, if you're going for a one-year commitment, they save in the order of 20 to 40%. The commitment level, there are two options. You can commit to 1 year or you can commit to 3 years. And they're available for a range of AWS services. So the most common is Amazon EC2 and EC2 hosts, which is the computing resource. But they're also available for databases, caching services, and CloudFront. With the final two, DynamoDB and database and CloudFront, they're not quite the same as reserving instances, but they are still a discount for commitment. So, in order for AWS to provide the discount, our product teams build out capacity based on what you reserve. And so that means we need customers to define what is required to be matched for their reserved instances to help us build out what you need. And so the first thing that needs to be matched is the instance type. The second is the operating system, so Linux, Windows, or anything else. The third one is the region, so for example, Sydney. And you can toggle between region or availability zone, which I'll go into detail shortly. And also finally, the tenancy, shared or dedicated. And so tenancy dedicated is used by customers who have licensing requirements around their software. And so there are a fair few different types of EC2 reserved instances. This table helps you understand that information in a more graphic way. And so as mentioned, there are 1 year and 3 year reserved instances. There are also standard and convertible reserved instances. And so convertible reserved instances came about because we heard the customer asking for more flexibility around reservations. Some customers didn't want to define all of those parameters mentioned 2 slides ago. So convertible reserved instances lets you change a lot of that. And released just this week, I believe, there were 1 year convertible reserved instances. And so you can also see that there's regional and availability zone specific. And so what a region is for the newer users is, for example, the entire Sydney region is considered a region. We have 3 availability zones within Sydney, and so you can apply your reserved instance to an availability zone if you like. And if you do, then you actually also get a capacity reservation. But if you decide to cover or use the reserved instance across the entire region, then you get the benefit of instance size flexibility, which I'll detail shortly. There are different payment models, so you can pay nothing upfront, about half of it upfront, or all upfront, and as you pay more upfront, you get greater discounts. There's also different operating systems, instance types, and tenancies. And note, you can easily switch between regional and availability zone specific at no cost. And the shaded items affect pricing. And so if you have any questions on this, reminder that there's a question box available and you can ask your questions there. And so convertible reserved instances were released based on customer asks around wanting reserved instances to be more flexible. And now with these, you can flex across instance families. So you can change from M4 to C4 to I3s to any instance that has convertible reserved instances. You can change size. So if you need to upsize your resource, you can change the reserved instance to match that. And if you need to downsize, you can do the same. You can change operating systems. And so some companies, in order to optimize spend, they have a strategic target to use more open source operating systems like Linux and CentOS. And so this allows customers who are taking that approach to change operating system to open source. And finally, you can change the tenancy as well. And so on the other side of the coin, you might be asking, okay, what are you actually committing to then? And so you are committing to 3 years or 1 year with the new option, and it's not refreshed on conversion. And so if you, for example, if you used 2 years up of your 3 years and you do the conversion, you still only have 1 year remaining. It doesn't pad the extra years on top. You are committing to a specific region, Sydney, for example. You are committing to EC2 on AWS, of course. And finally, you're committing to a level of spend. And so when you do the conversion, if you convert upwards to higher spend, it'll ask you for a sure up value. And if you convert downwards to a lower spend, it'll actually give you more reserved instances to maintain the level of spend. So one concept that is occasionally confused with convertible reserved instances is instance size flexibility. And so what that is making it easier for customers to take advantage of reserved instances, especially if the size doesn't match up perfectly. And so starting March 1 this year, the regional RIs that are Linux and have shared tenancy applies to all sizes of the instance within a family and a region. And so expressing that as an example, you can see that one M4 extra large reserved instance can apply to 2 of the smaller, one stage smaller instance type, M4 large, or it can apply to half an M4 2x large, which is 1 grade bigger. And so that means, especially with the newly released EC2 Cost Explorer console recommendations, it applies this concept, and it may tell you to buy many, many small reserved instances to cover your larger instance workloads. And so another question that comes up quite often with customers, especially larger customers, is understanding how reserved instance benefits apply. And so for customers that do use a payer account and linked account structure, reserved instances can be placed in the account that you want to get priority to get benefit first. So in this example, if we have, say, for example, a business unit that uses account 1, and they want the benefits of the reserved instances because they paid for them. And so what you can do is place the reserved instances in that account, and that will ensure that account gets first dibs or first priority to the benefits. When those benefits can't be used by that account, then they flow out randomly to the other accounts. For customers who don't care about that and have a central team paying for the reserved instances, quite often the reserved instances sit within the paying account instead. And so they can be placed there where the paying account gets the priority and the other accounts get randomly allocated the benefit if the paying account can't use it. If it does sit in the paying account, be sure to have RI console access to modify the reserved instances if needed, and access to the billing console is helpful to check reserved instance utilization. So speaking about reserved instance utilization, the AWS tool that helps you with that is Cost Explorer. And so high utilization means greater savings realization. Typically, customers set roughly a target of 90 to 95% utilization of reserved instances. And there are actions you can take if there are instances not being used. For convertibles, that is extremely easy. You simply convert the reserved instance to something that you are actually running. And released, I believe 2 days ago, is the new Cost Explorer reserved instance recommendations for EC2. So Cost Explorer has a look at what you're currently running in your environment and recommends some reserved instances to help you save money. And so when running this on my own environment, Cost Explorer recommended a few reserved instances, 3 in this example, and it saves about $1,700 per year. You can see on the right, there are also a few different options. So you can toggle between the 1-year option, 3-year option, 3 years saving more. You can toggle between standard and convertible, convertible with more flexibility, standard with more savings. And you can toggle the payment option, all upfront saving more, partial upfront and no upfront, saving a bit less. And finally, you can decide how many days into the past you want this recommendation to be based on. And so if you've made recent changes to your infrastructure or you've recently purchased reserved instances, you might go for an option like 7 days, which will take into account the latest updates to your system. However, if you want a longer term view or things haven't been changing that much over the past short period, then you can have a look at the 30-day option or the 60-day option. And finally, the last pillar is about leveraging the right storage class. And so I'm going to be talking about the Elastic Block Store that gets attached to computing EC2 and the Simple Storage Service S3 Object Store. So Elastic Block Store comes in 4 different flavors. Provision IOPS for higher throughput performance, general purpose SSD, which is the default. There's also a throughput optimized HDD and cold storage HDD as well. So as mentioned, general purpose is the default. However, keep in mind there are some other options. Throughput optimized is cheaper than general purpose, roughly about 2 factors cheaper, so half as expensive. And finally, cold storage is even cheaper for workloads that don't need to access the data or have high throughput. If you use Simple Storage Service, there are also different forms of Simple Storage Service with cheaper options towards the right. Hot workloads, which is the default, is really for active data that is used quite often. Warm workloads are for infrequently accessed data. And finally, cold storage is for archiving data. And so keep in mind the way in which these things are charged are somewhat different to each other. And so cold storage considers the number of objects being stored. And so how some customers reduce that cost is by zipping together the files into a single file and then storing it that way to reduce storage cost. Warm storage considers the amount of data you access over the entire environment in any given month. So as a rule of thumb, for Sydney, the rough break-even point between hot storage and warm storage is if half your data in a given S3 bucket is accessed in any given month, then hot storage breaks even with warm storage. If less than half your data is accessed, then warm storage is a bit better off. And so you might ask, okay, that's all well and good, but that sounds like a bit of effort. And so what AWS provides is a service called S3 Analytics, and it tells you what storage is hot storage versus what storage is warm storage. And you can apply policies within this service to automatically transfer files and storage into warm storage or infrequent access, where the system detects that it is. To go into a lot of detail here, but beyond these 4 pillars, there are many, many more ways to save. They range from consolidating the billing accounts into a single account to take care of volume discounts, releasing unused resources like elastic IPs, serverless, switching to application load balancers. Many larger organizations are going down the path of containerization. What I'll describe in a little bit of detail first are 2 things, the CloudFront and CloudFormation. So CloudFront, as the name suggests, is putting the distance between where your data needs to go. So describing that as offloading your architecture to CloudFront means the distance which your data has to travel is shorter. So CloudFront has edge locations around the world, and think of it as a distribution center for your data to get to your customers quicker, and it caches that data. And so I've seen customer environments be able to save half their cost with better performance by applying CloudFront architectures. The second one is CloudFormation, as demonstrated earlier with the 2 examples. And so what CloudFormation does is, through automation of through CloudFormation, you're able to save a lot of time of your teams and developers. So you can see in the 2 solutions I deployed, not only did I not build that solution myself, the deployment time was in the order of minutes. And secondly, it reduces the incidence of manual errors of setting up your infrastructure yourself fresh each time. And so before I move on, I'd like to give you a quick demonstration of Cost Explorer to navigate costs and RI provide reserved instance recommendations. And so you can see Cost Explorer and access Cost Explorer by clicking the drop-down and going to My Billing Dashboard, and there'll be a button that gives you Cost Explorer. And so in the example here, I'm having a look at monthly costs by service. There are a few different pre-baked reports within Cost Explorer, and you can save your report after you configure it as well. You can look over the last period up to a year. You can look at daily or monthly data, and it lets you answer questions around what am I spending, how's it trending, and where am I spending it? So in this example here, I can see that most of my spend in the recent month of October goes towards EC2 instances. I use a little bit of Elasticsearch, a bit of Redshift, and very little of other services. And so when it comes to optimization and targeting of effort, what I would target is first the EC2 instances with the methods described so far. Then I might have a look at Elasticsearch, and then I might have a look at Redshift. And once I feel like I've optimized those 3, there's very little further room to go. This service also lets you bring in tags as well. So tagging of resources lets you tag applications and owners, and you can say, okay, let's filter for the resources I actually manage and own. And as mentioned, newly released is the reserved instance recommendation sheet, and that's also available through Cost Explorer. And it's accessed by this little side menu here, down the bottom, recommendations. The next demonstration is Trusted Advisor. And so Trusted Advisor, as mentioned, comes with business support and enterprise support. And it provides recommendations and advice along a few different dimensions. So it provides cost recommendations, performance recommendations, security recommendations, fault tolerance, and service limits. And so given the context of this webinar, I'm going to dig into cost optimization. And you can see here, it's suggesting I have potentially about $1,800 worth of monthly savings. And so where that comes from is checks against EC2 reserved instances expiring, EC2 reserved instances additional that I can reserve. However, nowadays, a more feature-rich report can come from Cost Explorer, as mentioned. Idle load balances, low utilized resources, so resources that are have low CPU average utilization. So this helps you detect idle resources, whereas the EC2 right sizing solution in the first demonstration actually helps you recommend new instances. Underutilized volumes, underutilized Redshift database, idle databases, Route 53 resources, and unallocated Elastic IP addresses. And so leveraging Trusted Advisor, typically able to identify savings and target those savings for action. So all of that is very nice to know. However, typically from a commercial management perspective, you may have some more questions around how do we actually action this and drive this in our company? And also, how do we do cost tracking and cost forecasting? And so at Amazon, we like to talk about the fact that good intentions never really work. You need mechanisms to drive action and results. And so some of the mechanisms for optimization that we've observed that new customers adopt include, firstly, defining, agreeing, and enforcing cost allocation tagging. So as a newer customer, your environment might be small enough and you may have only one team who uses the environment. And it's easy to ask engineers, oh, what is this resource for and how much does it cost? However, especially as organizations grow and their AWS footprint grows, tagging becomes more and more important. And so good practice to start this early is to start implementing tagging policies and enforcing them. And so what tagging lets you do is it drives allocation, so you can see the costs and how they're allocated within tools such as Cost Explorer. It lets you do show back, so it lets you show teams how much they're spending and how much each of their applications cost. It lets you do charge back, so eventually many larger organizations get business units to pay for their IT costs rather than absorb it as a central budget, which then in turn drives ownership and smooths out the drive for optimization and efficient behavior. The second is using out-of-the-box tools. So many engineers and engineering teams like building things. I'm myself an engineer, I love building things. However, from a time efficiency perspective, you may want to use out-of-the-box tools to build things that drive business value as opposed to building things that help with optimization. And so some tools that are useful for that purpose are third-party cost management platforms like Cloud Health, Cloud Checker, and Cloudability. We've also got organizations that specialize in identification of optimization opportunity. So Stacks provides reporting on where it thinks there is wastage occurring. And as mentioned earlier, Gorilla Stack provides automation support for resource scheduling. And there are also AWS native tools provided at the link below. And finally, defining metrics, setting targets, and reviewing. It's difficult to understand if you've improved if you don't measure anything. And so it's about defining the right metrics and setting targets and reviewing. Many newer customers tend to define optimization by the percentage saving they experience on the platform after optimization activities. That can work. However, at the same time, if you are deploying new workloads, then it's difficult to use percentage savings as a optimization metric. And so what more mature customers tend to do is measure separate metrics along the dimensions of the technical levers described earlier. So what is my reserved instance coverage and utilization? To what degree do I turn off workloads on weekends? So you can see on Cost Explorer, how much cheaper is my weekend spend than my weekday spend? And finally, using right-sizing tools that tell you how much additional savings are available through sizing your resources smaller. And so putting that all together, it's about tagging and allocating and driving ownership. It's about using out-of-the-box tools, and it's about using metrics. And so leading towards the close, there are some finance team considerations as well when migrating to the cloud. And because cloud is quite different to traditional infrastructure, to best take advantage of cloud and to realize the most value, there are some considerations and assumptions that need to be addressed. The first is that costs are largely static and predictable once they reach the BAU budget. And so in traditional infrastructure, quite often the IT budget is part of BAU budget, and it's fairly static because you've spent large amounts of capital up front and it's simply sitting in the data center now. So when it comes to cloud, that may no longer be the case, especially when you optimize and scale according to actual demand. So newer customers, one option they take is asking for forecasts from engineers, and engineers can get quite good at doing this. However, a more advanced option used by larger customers is actually removing budget for non-static costs, so scaling costs, and finance starts to step into the realm of measuring efficiency and evolves their role. So they measure efficiency through spend per revenue, or spend per developer, or spend per essentially business outcome. The second is that approvals for projects and associated costs occur upfront. In cloud, this may no longer be the case, and so some customers put in place approvals for any spend in cloud. However, that may hamper your ability to innovate and be agile. And so other customers who have evolved this process do things like placing approval gates at transition from project spend, so when it's testing and innovating and trying things out, between the project and BAU spend. When it's baked into BAU spend, there's an assessment of whether the business value drivers were met, and if they were met, then all good, approved to go ahead into BAU spend. So before I move on, that requires a bit of interaction between finance and engineering, and I've seen for customers where that occurs, the best outcomes are realized. And finally, IT is typically in traditional infrastructure treated as a cost center. So people don't have, especially business units, don't care too much about how much IT spend is because it's not theirs to pay. And this can be addressed in cloud through tagging and enforcing tagging to start, enabling showback. But mature customers tend to move towards using chargeback. And so what tagging and enforcing tagging do is also allow you to run all of the reports off of the same cost allocated data, and you can assign ownership through chargeback. Of course, money speaks, and when teams have to pay for their IT usage, they become interested in the long-term outcomes and the long-term spend of IT. And so if you're ready to migrate over to AWS, we also provide resources to help you calculate the total cost of ownership pre-migration and post-migration. And so one of those resources is the TCO calculator. All right, closing out now. Next steps for you. We've mentioned a lot of material in this webinar, and we don't expect you to remember all of it. And so what we have in Australia is the Cost Optimisation Interest Group. And so what this interest group does is customers gather together and we share practices, best practices and customer stories and learn from industry experts on how to execute on optimization. And so feel free to join the group via the link below. So next steps as well is we have a technical essentials class, exclusive access to our webinar attendees with limited seating. And they're occurring in Melbourne and Sydney there. So feel free to sign up by emailing ANZ Marketing, AWS-ANZ-Marketing to secure your seat or speak to your account manager. This webinar is part of a 3-part series. And so today was optimize the cost and efficiency of your AWS architecture. Next up will be on 30th of November, how to build your business case for cloud and how to engage your business stakeholders. So to make your cloud migration a success, like thousands before you, there are some case studies available as well. So there are 3 case studies mentioned here for the larger customers who have experienced significant success stories: Atlassian, Capital One, and NL. And many other case studies and on-demand events and videos are available at the final link below. So what will come up on screen now is the poll surveys of what you thought of this webinar and whether you enjoyed it and its content. During this time, we'll also go to 10 minutes of question and answer, which I'll look to address now. So the first question, reduced redundancy storage. Reduced redundancy storage is being deprecated, and today it's actually much better to go for infrequent access storage. When I say much better, I mean typically better pricing and better performance. And so our documents are being updated to reduce the reduced redundancy storage mention. Essentially, infrequent access is the equivalent and better solution. Another question. At the moment, when you create an account, you need a credit card for billing purposes, which is okay. But if I want to create an account for the company which I work for, is there an alternative to using credit card invoices paid by other methods? Yes, there is. Reach out to your account manager and ask for the option of a PDF or paper emailed invoice. And so you can pay invoices on the invoicing terms, and essentially it doesn't have to be linked to your credit card. Glacier is okay for backup, where a zip file is loaded each day. Yeah, that works. So if you have an automated process that zips your files within your S3 buckets for each day's worth of work, and so Glacier has, when you try to retrieve the storage, there are quick versions and slower versions being cheaper. If you don't see yourself needing that data extremely quickly, then Glacier is a very good option. But if you feel like you may need that data ever so often, infrequent access, it can be a good option too. Got another question. I use Elastic IP because the public IP changes as EC2 instances stopped and started. Is that the best approach? I would talk to my solution architect about that question, and because that may depend on your specific workload needs. So please reach out to your solution architect about that one. Is there a cost if we exit from RI within a year? So in order to exit from RIs, for standard RIs, there is a cooling off or cancellation period over 30 days. So between initial purchase and the 30-day time mark, you can reach out to your account manager and support to cancel the RI you've purchased without any adjustments or questions. Typically that's done because maybe there was a mistake during RI purchase, or you simply decided that you don't need it anymore. For 3-year standard RIs, the standard term is 90 days cancellation. After that period, there is the RI marketplace, which requires a US bank account, but you can sell your RIs there to other parties or other customers that could make use of those RIs. Unfortunately, other than those options, there aren't any further options to remove the RI within a year, and typically customers should understand their workload is likely to run for the next year before buying an RI. Keep in mind, because of the payback period of the RI, so for example, if an RI saves about 30%, that means the payback period is about 8 months into the term. So after 8 months, it's equivalent as if you were paying it for free compared to on-demand. You mentioned to link the presentation. Yep, that will be shared after this webinar via email, so look out for your inbox for this presentation. Say in 6 months we move or decommission. So it sounds like that's related to the RI question. So the best option there really is the 1-year convertible reserved instance, which commits you to 1 year worth of that level of spend. But if you decide to move your workloads or do something else, then you can still change that reserved instance. The recording, yes, will be available for download, so look out for your email there. Is there an RDS instance scheduler? So unfortunately, there isn't a pre-baked RDS instance scheduler yet that I know of. However, I have worked with customers whose engineering teams have developed their own RDS instance scheduler. So at the moment, you'd have to build that yourself. But in the future, I imagine AWS teams would release open source material on that. Got another question around RI coverage. So what's the best practice around RI coverage and strategy? So I've seen customers, especially advanced customers, for workloads up to about 50% of the workload, use standard RIs to maximize the savings. And for the remainder, use something like convertible RIs to cover off the top. And what that lets you do is, even if your workload changes, there is a good amount of room to wriggle with the convertible RIs. Got a question on TCO. Are there any tools for assessing CPU and RAM before migrating to AWS? Yes, there are. So typically, we see customers using things like VMware and their vSphere suite in order to migrate workloads to AWS. So understanding what is the CPU used and what is the RAM used before migrating, so they can pre-size their resources smaller so that it saves time in the long run, avoiding resizing. Industry averages, I understand there is industry research on what is the typical average peak CPU and typical average peak RAM, and that's in the order of 40 and 60%. So you can size resources smaller on the get-go, and on migration and post-migration, you assess its performance and leave time in the project timeframe to do performance assessment and upsize as you need, as opposed to migrating exactly like for like and then spending significant amount of time downsizing afterwards. What are the cost allocation tags typically used by customers? So I see many customers use different tagging policies. Some customers use very few tags, some customers use a fair number. So larger customers I've worked with, Atlassian, they use 5 different tags or 5 different mandatory tags. The first one is the technical owner, and you always want to be able to contact your technical owner if there is a recommendation to change. The second is environment, dev test staging versus production. That lets you group together those resources in tools like Cost Explorer and understand, okay, across all of my dev test resources, what is the degree to which they're turned off? And you can break that down by business unit as well. So the third tag being business unit, you can see which business units are doing well in cost allocation and turning resources off versus which business units are not doing so well. The fourth one is the automation tag. And so as mentioned in the instance scheduler example, you can apply tags to define what automation it goes through, especially on and off. And finally, for larger organizations, the cost center matters a lot. So you specify the cost center in the tags, and your reporting can show which cost center the tag belongs to support finance needs. Instance size flexibility for EC2, can that work with Windows and not only Linux? Unfortunately, at the moment, it is only Linux. Instance size flexibility for EC2 Windows may come later, but no time frame yet. So got a question. If I brought a 3-year convertible RI and from 2-year on, I want to change the instance type from T2 micro to T2 large, how is the price adjusted? So let me give you a numerical example. So let's say you bought one T2 micro 3-year convertible reserved instance, and let's just say, for example, it costs $9. And so after 2 years passes by, assuming you bought it all up front, then the remaining value is $9 minus $3 in the first year, and then minus another $3 in the second year. And the remaining value of that RI is now $3. And so if you need to convert to a T2 large, it has a look at the remaining value on that RI, which is now $3 because you've used up $2, and it uses that $3 to offset the remaining 1-year commitment after you change to a T2 large. And so it asks for a sure-up value to pad up the value to what the T2 large is worth, but you get to take advantage of that $3 left. Let me go in the questions in order. So okay, how to optimize reduce costs of volume gateway, as it is not yet possible to apply a lifecycle policy to the instance yet. Unfortunately, I'm not familiar with optimizing volume gateway. However, feel free to reach out to your solution architect or account manager to get advice in that area. VM, what GPU VM instances are available? Not for gaming, for deep learning and machine learning. So this is stretching my realm of familiarity a little bit, but at a high level, I understand the G series. So I believe G3 is available in Sydney now, and so you can take advantage of the G3 series for GPU needs. From that perspective, please double check on our websites around the specifications of the machines plus their recommended purposes. How do you manage right-sizing a DR load? So I would talk to my solution architect about that. There are many, many options around how to maintain high availability and address DR. Because Sydney has 3 availability zones, what some customers do to optimize DR, not quite right size, but to optimize, is operate an active architecture, which means you run your 100% workload across 3 zones with a bit of buffer across each. And so if you provision 150% of the workload across 3 availability zones overall, then even if one availability zone goes away and you lose 50% of that 150, which is 1/3, then your application is still live and running. From a right-sizing perspective, it's typically what customers do is they exclude DR workloads from the right-sizing. So, of course, DR being DR, it doesn't run actively. You'd see low utilization there, so that gets excluded from the recommendations. So watching out for time here, I've extended right onto the hour here. Unfortunately, I won't be able to answer any more questions here, but our account team will reach out to you for any unanswered questions remaining. So I hope you enjoyed this webinar. The recording and presentation will be sent over, and thank you very much for attending.